Now we discuss function. Function is a relation in which every element of a set A gets related to exactly one element of set B. So if we consider set A and set B, so set A contains 4 elements 1, 2, 3, 4, B contains 1, 2, 3, 4. So the function defined as a relation in which every element of this set A gets related to exactly one element of set B. So each element of A should be related to exactly one element of B. So if we consider that 1 gets related to 1, 2 related to 4, that is square of this number. So then 3 square 9, 4 square 16. So there is no element 9 and 16 in B. So here this is not a function. Why? So here 3 and 4 two elements is not related with any element of B. So it does not fulfill the condition to be a function. So let's consider another example, and here we consider A containing 4 elements 1, 2, 3, 4, and B consider as 1, 4, 9, 16 and 25. If we relate each element of A with its square within the set B, then 1 gets related to 1, 2 gets related to 4, 3 gets related to 9, and 4 gets related to 16. So each element of A related to exactly one element of B. So 1 is related to only one element A. So A1 does not relate any other element other than 1. So this fulfills the condition to be a function. So this becomes a function. Okay, but here 25 it's remaining, so we will discuss about it. So to be a function, each elements of A should related to exactly one element of B. This example fulfill the condition, so it's become function, and this does not fulfill the condition, so it is not function. We show a example. We take A as one element 1, 2, 3, and the set B has element root 1, that is 1, root 2, minus root 2, and root 3. So if we relate like this, 1 goes to 1, 1 is related to 1, and 2 is related to plus root 2, and 2 is related to minus root 2, and 3 is related to root 3. Then we see if the condition to be function is satisfied or not. So each element of A is gets related to the element of B, but here is said that each element of set A gets related to exactly one element of B. So each element should related to exactly one element of B. So here we see that this element 2 of the set A is related to two element of B, that is 2 is related to plus root 2 and minus root 2. So one element is related to two elements of B. So this does not fulfill the condition to be a function, so this is a not function. So previously we have seen that. So in this example we see that in the set B there is a element 25 with which any one element of A is not related, but it is a function. So it can be happen that like this, if we choose A having element 1, 2, 3, 4 and B having element 1, 4, 9, 16. So if we relate like before, so 1 related to its square 1, 2 related to its square 4, 3 related to its square 9 and 4 related to its square 16. So each element of A is related to exactly one element of B, and here in B there is no element other than this 4. So here each element is related to each element, so it is a special case, and we say this function as 1 1 function, that is one element goes to one element of the other set. So 1 1, it has a other name, that is injective. So there is other function like opposite of 1 1 is many 1, and here is one element remain in the set B. In this situation this function is called into function. So opposite of into there is onto function. So when there is no remaining elements, so it can be onto function.